Infisical's secrets management product helps teams manage sensitive data. Things like API keys, database credentials, certificates, environment variables, and tokens across their infrastructure. And when we talk about secrets, we're really talking about any sensitive value that a user, application, pipeline, or service needs in order to run. Whether you're working in local development, running CI/CD pipelines, or deploying to production in Kubernetes, Infisical provides a consistent way to manage and deliver those secrets securely. In this video, I'm going to walk you through secrets management in Infisical at a high level, so you can understand how all of the pieces fit together. Infisical is organized around a simple hierarchy: organizations, projects, and environments. At the top level, you have an organization. That usually maps to a company or a team. An organization can contain multiple projects, each focused on a specific product or use case. In this video, we're going to focus specifically on the secrets management product type. Now, within a secrets management project, secrets are split into environments. This is where you separate things like development, staging, production. You can also have multiple production environments, for example, different regions or tiers, while still managing everything in one place. Beyond environments, Infisical also supports additional logical scoping, like folders, which lets you further organize secrets within an environment. For example, separating secrets by microservice. Together, environments and folders give you structured ways to separate secrets around things like services, regions, or teams. This structure is important because it gives you isolation by default. Secrets don't accidentally bleed between environments, and access can be scoped very precisely depending on where a secret is meant to be used. You'll also notice that Infisical gives you a bird's eye view of secrets across environments, showing values side by side. This makes it easy to spot missing secrets, inconsistencies, or differences between environments before they cause problems. When you need to go deeper, you can also drill into a specific environment. Here you can inspect or manage individual secrets. Now, at the most basic level in Infisical, secrets are key value pairs, a name and a value. But that doesn't have to be a simple string. I'm going to reveal these as these are all test secrets set up for this demo. A secret could be a multi-line value, like a certificate or private key. It could be structured data, like JSON, or even a value composed of other secrets that already exist. Those reference secrets can live in the same environment or in a shared environment that's imported elsewhere. This lets teams define common values once, like credentials, endpoints, or certificates, and then reuse them safely across environments without copying them around. This flexibility is important because as systems grow, duplication becomes one of the biggest sources of risk. When the same value is copied into multiple places, changes become manual, environments drift out of sync, and mistakes start to happen. Infisical avoids that by acting as the central source of truth. Instead of duplicating values, secrets can be built from other secrets. For example, our database connection string might be built from secrets that were defined elsewhere. When either value changes, everything that depends on that value updates automatically. This results in less drift, fewer manual updates, and a much smaller blast radius when something does change, especially in production. And every time a secret changes, that matters. If something breaks, you need to know what changed, when it changed, and how to undo it. In Infisical, every secret is automatically versioned. Every time a secret is updated, a new version is created. This allows you to inspect how the value of an individual secret has changed over time. On top of that, secrets can contain metadata like tags and notes. This becomes really important once you have hundreds or thousands of secrets because it gives context, what a secret's for, who owns it, and how it's used. Infisical also supports point-in-time recovery, which lets teams capture the state of an entire folder or a set of secrets at a specific moment. Rolling back to a snapshot allows multiple secrets to be restored at once. This is especially useful when bad changes affect more than one value. This builds on top of individual secret versioning, giving teams both fine-grained and broad recovery options depending on the situation. Together, these features make secret changes safer and easier to recover from when mistakes happen. Secrets are only useful if they can be delivered securely to the places that need them. So once secrets are defined and organized, the next question becomes how they actually get consumed. Infisical supports many delivery methods depending on where your workloads run. For local development, teams often use the Infisical CLI to inject secrets at runtime. This lets developers run applications without committing secrets to files or source control. In CI/CD or production environments, there are multiple ways to deliver secrets, and the right approach depends on how your systems are built and deployed. For example, Infisical provides an agent that can run alongside workloads and handles secret injection securely. In Kubernetes environments, Infisical supports multiple approaches. Teams can use the Infisical Kubernetes operator, the Kubernetes agent injector, or the Kubernetes CSI provider to deliver secrets directly into clusters. The Infisical Kubernetes operator can even auto redeploy pods when secret values change. And for teams that are already using it, Infisical also integrates with External Secrets Operator, a widely adopted tool in the Kubernetes ecosystem. This allows Infisical to act as the backing secrets provider without changing existing workflows. Under the hood, many of these integrations can authenticate using workload identity rather than static credentials. For instance, an Infisical agent running on an AWS EC2 instance can authenticate using AWS Auth, while the Kubernetes operator can authenticate using Kubernetes native identity. This allows workloads to prove who they are at runtime and fetch secrets securely without embedding static credentials. Infisical also integrates with common CI/CD systems, cloud platforms, and infrastructure tools, so secrets can be fetched dynamically during builds, deployments, or runtime. And in cases where systems still expect secrets to live elsewhere, Infisical supports secret syncs. This allows Infisical to remain the source of truth while pushing secrets out to other platforms, such as cloud-native secret stores, in a controlled and auditable way. Across all of these methods, the core idea stays the same. Secrets are delivered when they're needed, access is identity-based, and long-lived credentials aren't scattered across your infrastructure. Now, at some point, secrets stop being a tooling problem and start becoming an access control problem. Not everyone and not everything should be able to access every secret. For example, most engineers might have access to development and staging secrets, while production secrets are restricted to a much smaller set of trusted users or systems. Infisical handles this through identities. An identity can represent a human user, like a developer or an admin, or a machine, like an application, a CI pipeline, or a background job. And access is granted through roles and permissions, and those roles can be scoped very tightly by project, environment, and even by secret path. This makes least privilege practical instead of theoretical. For instance, a CI/CD pipeline might be represented with a machine identity, and this identity might have a custom role that only provides access to the specific production secrets it needs during deployment and nothing more. Access can also be temporary. If someone needs production access to debug an issue, you can grant just-in-time access for a limited period, and it's automatically revoked when it expires. That applies to both humans and machines. The result is that secrets are only accessible to the right identity in the right place for the right amount of time. Once secrets are being accessed and changed by multiple people and systems, visibility becomes critical. You need to know who accessed what, when it happened, and why. Infisical provides audit logs for both human and machine identities. Every access and change is recorded, along with useful metadata like timestamps and source information. On top of that, access itself can be gated through approval workflows. Developers can request access to specific environments or secrets, and those requests can be approved or denied based on policy. And changes to secrets can follow a similar pattern. Instead of pushing updates directly into sensitive environments, teams can require approvals before changes are applied, much like a pull request workflow. This adds safety without slowing teams down, and it ensures that sensitive changes are deliberate and traceable. Secrets management isn't a one-time setup, it's an ongoing process. As systems evolve, secrets need to be rotated, regenerated, shared temporarily, all without breaking applications or creating unnecessary risk. Infisical supports secret rotation, allowing teams to regularly update sensitive values like credentials on a defined schedule. This reduces the risk of long-lived secrets and limits the impact of accidental exposure. Building on that, Infisical also supports dynamic secrets. Instead of reusing the same credential, secrets can be generated on demand, scoped to a specific identity, and automatically expire after a short period of time. This model dramatically reduces blast radius. Even if a credential is exposed, it's short-lived, unique to that workload or user, and automatically revoked. There's no shared secret to rotate or clean up later. And Infisical integrates with a growing set of external systems, such as databases, cloud platforms, and other infrastructure, so credentials can be issued dynamically at runtime rather than stored long-term. And for human workflows, secrets can be shared using temporary expiring links instead of copying values into chat tools or emails. Together, these capabilities allow teams to manage secrets safely as their systems grow, moving from static credentials towards short-lived identity-based access without adding operational overhead. At a high level, good secrets management comes down to a few core principles. Secrets should be centralized, scoped by environment and identity, delivered securely at runtime, and fully auditable over time. Infisical brings all this together in one system, so teams don't have to choose between security and developer velocity. Wherever you're working, local development, CI/CD, or production, Infisical provides tools and patterns that fit the setting you're in. This video was a high-level walkthrough of Infisical secrets management. From here, you can go deeper into specific workflows like CI/CD, Kubernetes, dynamic secrets, or access controls, depending on what you need.